monitoring system. Before we dive into our project, let us introduce our team. Our team consists of team leaders, software engineer, design engineers, and a researcher. So, our country Malaysia is known for its rich biodiversity and vast river networks that face increasing threat from water pollution. Waste from factory and sewage contaminates water sources, making them unsafe and for daily use and harming the ecosystem. To address this issue, our team aims to develop a river pollution monitoring system using smart sensors and cloud-based analytics that aims to provide a real-time pollution data, allowing for faster response, contributing to a healthier environment.
Alright, for the next slide, let's take a look into the problem statement which inspired our team to do the prototype project. River pollution in Malaysia, driven by industrial, agricultural, and sewage waste, poses a risk and disrupt daily water use. Current monitoring systems are inefficient due to mandatory samplings, delays, and cloud-dependent alerts that exclude rural areas with poor internet access. This gap necessitated near real-time offline compatible solutions and ensure rapid response and equitable access to pollution alerts. Next slide. So this is the existing system to monitor the river water quality and use which encourage us to do the project. So, and this is our proposed system overview from the data collection and the warning message displayed on the digital signage board. Let's understand our proposed system through the next demo animation. When the sensor detects unstable or water quality, it will send data to the signal to the local server, then the local server sends signal to the GMA and cloud for data storage and near real-time monitoring. The prepared warning message for GMA is transmitted to QZSS and then to the FSS, and the expressor will decode the message and display warning message on the digital signage board.
So, for the purpose of the void design is preparing a stable floating body and enclose the charging compartment and advanced sensing capability. The floating body will ensure the sensor will avoid water for accurate interpretation, and inside the charging compartment comes the transistor, phase sensor, and node MCU.
Sudah aku ni,
The data
kau tiga.
transmitter. So the void contains
Kat foyer tu.
pH level, transmitting real-time water quality, and so the environment for visual.
My God, bagus.
Okay, so here's our results from our demo. So first, we get our results from the sensors and we upload the results to the cloud, and we put it in table. So within the time, we will say the water quality is critical, and we will send the email to the JMA to send the KZSS EWM message. So here's our message that we got from the KZSS to our presence. And here's our small demo that we did. So as you can see below here, we put the sensor, and then you send an email to the JMA, you send to the KZSS, and in response, we will send the signal to the presence. And then in our case, we use the I2C to display our output. So it will say something like water polluted, and that's it for the demo. So what are the impact that the community will get is they get early detection on the contaminants. This will prevent waterborne diseases. So other than that, they also get alert about the polluted water that can prevent people from using it for drinking, bathing, or irrigation. So residents also receive notification about the unsafe water conditions, so that it will allow them to take any precautions beforehand. And the benefit for the communities is, so in Malaysia, rivers are mostly used by the fishermen, farmers for their local business, so that clean water can help them to avoid losses. And river also support by diverse ecosystem, so which give fishermen and farmers income. So other than that, it also attract tourism for recreational activities and also contribute for local economy. So eventually, this also will be given for the lead to development of a remote area. So that's all from us. So, thank you.
Thank you. Any comments or questions from judges? Okay. We have one question from judges.
Okay, thank you for your presentation. That I think that to detect water pollution, right?
Mm-hmm.
Using the pH sensor maybe is not sufficient.
Mm-hmm.
Do you have any idea that when if for real use, right, in practice, what kind of sensor that you think that it should be important?
Yes, so we initially planned for more than one sensor, but because of budget restrictions, we only got the pH sensor. So other sensors to detect river pollution are turbidity sensors and dissolved oxygen. So those three are our target sensors actually. And aside from that, we could also use the camera for AI detection to detect rubbish, but we didn't have enough time to explore more on the edge impulse.
So when you use the multiple sensors, right, and then you're gonna think about your node MCU, right? So you install on the same node MCU, and what the communication link that you're gonna to use to send the data from your sensor node to the server to the cloud.
Okay, so for this, the collected data will be uploaded to the cloud. So the cloud will be the center connection for everything. So we use Wi-Fi to send all the signals to the cloud, and we give the access to the cloud for the ground station so that they know they so that they could produce the signals whether the water is polluted or what are the signals that they should send to the communities by doing that. So to upload the message to the cloud, we use Wi-Fi, and we plan to implement this in the rural area also. So in that we try to use LoRa as a communication module.
Okay, sorry, time's up.